Hi. I didn't. Zoom just said to me there was like a robot voice that said "recording in progress," which I've never heard before, and I hate. It's super creepy. Um, Hello, everybody. I'm Martin. I'm a senior crafter at 8flight, and this is a talk that I wrote and prepared for a conference called Bang Bang Con, which I love. It's all about the sort of joy and curiosity and excitement of computing. Um, and the talks that you do for Bang Bang Con are about 10 minutes long. So I know this is booked in for like an hour, but you will be highly likely to get quite a good chunk of time back, which I think is usually preferable to when someone tries to be a half an hour talk that then goes on for 90 minutes. But just to manage expectations up front, I do not have like 45 minutes of material for this. It's about 10 minutes. But I wanted to talk to everyone today about the past, which is when I used to feel young. And I am so proud to admit that the first MP3 that I ever downloaded was Ricky Martin's absolute seminal 1999 Latin pop banger, Livin' La Vida Loca. Now, if anyone in this room is one of those fancy modern Zoomers who isn't old enough to know what an MP3 file actually was, um, allow me to show you briefly what life was like if you were a nerdy millennial at the turn of the century. So, this is Windows 98, and I would play my Ricky Martin MP3 dozens of times a day on an outstanding program called WinAmp. And this is what it looked like. WinAmp, you could also put loads of cool skins on it to sort of customize the way it looked. It was brilliant, and I think it might be the first piece of software that I would probably be proud to say that I loved. Um, and on Winamp, I also listened to a lot of Nirvana and Rage Against the Machine, which compared to Ricky Martin creates a particularly flavorful juxtaposition. But the actual MP3, now I downloaded all of these hits from the MP3 file sharing service called Napster. Now, if you missed Napster, this is what it looked like. And it introduced what was called peer-to-peer networking to the world, which is not something we talk about too much these days. But back then, it felt incredibly edgy and super punk and really anti-establishment. And despite what the music industry was saying at the time, it was so obviously, like to me, like staring at a portal into the future. And one of the things we do at 8flight is our apprenticeship cohorts, which Nicole mentioned at the start, which is where we mentor our future crafters through our internal apprenticeship program. And one of the projects we often ask our apprentices to do is to create a HTTP server from scratch. So moving from the individual sort of low level building blocks up to this pleasant, reusable abstraction, and maybe even making a sort of library out of the HTTP server that you've created. Now, I've been mentoring this project myself recently over the past few months. And at the same time, it really got me thinking about Napster again. And more specifically, whether I could recreate my own Napster, my own sort of peer to peer network. Um, and so I had a look. It's been a really fun journey that I'm really excited to share with you today. And it took me through the world of internet sockets, numerous servers, and eventually playing an MP3 file that I downloaded. And I kind of started thinking about this because I was thinking, like, how different could a centralized peer-to-peer service be from a classic HTTP server? So I'm going to start today with what I'm going to show today is a very brief, very top line tour through kind of the architecture of Napster, and then how we might go about creating a very basic command line application that uses peer-to-peer file sharing. So here we are at a screen, which I'm going to say is the very beginning. This reference comes from a pretty amazing reverse engineered Napster called OpenNap. The actual Napster, the innards of it are sort of have been lost in time. But a group of people at the turn of the century sort of, they snooped on all of the messages that were being sent through the network and have sort of composed what they believe is a pretty accurate representation of how Napster probably functioned. And that's what we'll be sort of drawing our own inspiration from today. And so way back when, after booting the Napster client on the Windows 98 machine, the application would call the red redirector server at the sort of the top of my server stack there. And this is kind of what we'd like to think of as what we would think of as a load balancer today. The redirector server would point you to a nearby Napster server that hopefully wasn't completely overloaded with other clients at the time. You would then connect to that server. The rest of your communication would go from the server between you and the server that the redirector had sent you to. We're not really going to worry about the redirector anymore. But all of these connections, whether that's to the redirector server, the main Napster server, or even to another client, which is where the peer from peer-to-peer networking comes from, are handled by sockets, which are actually provided to us by our operating system. You probably have a bunch of socket connections going on right now, with at least one being used to watch this talk. Sockets kind of power the entire internet. And if you have a program called netstat installed, you can run that command yourself and you can take a peep at what's actually going on your machine right now. Now, this is all thanks to this incredible socket API, which is originally written in C, but and I don't know C very well, so I won't be able to share any actual C code with you today. But almost all languages have an abstraction of this API as part of their standard libraries. And so we'll be using Python today because Python includes literally everything in its standard library. But if you've never used Python, don't worry. A lot of the syntax I'm hoping will be pretty familiar if you have enjoyed another dynamic language like Ruby or JavaScript. And so diving into some code, we load up this socket library in Python. So this is the library that's the sort of abstraction of that lower level C API that runs through our operating system. And we can declare a variable to represent an internet socket. Now, there are quite a few types of socket, but for today's purposes, we're only going to be worrying about internet sockets. So that's what we're looking at for the rest of the talk today. And we'll also be strictly communicating with the TCP protocol. Now, again, there are other types, but we've gone with TCP because it creates a reliable two-way connection. And with those two things, we can create a socket. And before we jump into Napster, I thought we'd actually have a look at HTTP. So we can fire off some binary data to the 8th Light server. And we can even put in a couple of headers to give it that look of legitimacy. And we get this cool response back. Now, this turns out to be some nifty HTML telling us to use HTTPS. So not the most exciting response in the world. It's pretty cool, but what's actually going on here is we're using the sockets API and TCP and all of this stuff, and we're not really worrying about how it is actually working. We're not really thinking about it at all. What we've done is we've taken some data and we've wrapped it with some HTTP protocol headers. That's work that we've done using Python. But then this in turn gets wrapped in more headers by our socket library. And then some IP data headers get added. Again, this is actually we're not doing this. This is sort of being added for us as a convenience. And then some hardware data, like your Ethernet port or your Wi-Fi connection, gets sort of popped on at the end. Now, we're going to whiz this data down the magical internet pipes to the 8th Light server. And the 8th Light server picks up this packet of data. And it sort of does the same thing in reverse. So it starts to strip off headers one by one. And then it gets back down to the original data that was sent. This is known as the layered network model, and I've given an incredibly broad overview of it just there. But what it essentially allows us to do for our intents and purposes here is we can focus on the code of our application. And it also means I can give this talk without having to fully understand about 1,500 pages of network programming. And so when it comes to our Napster server, we're still using IP and sockets and TCP. All of those parts are kind of the exact same. But while our connection to 8thlight.com knew how to speak in HTTP, we need to make a server and a client that can kind of speak in Napster. And actually setting up that socket infrastructure is very similar for both our client and our server as to how it was with our HTTP request just a second ago. So for the client, we create the socket using our Python abstraction. We connect to the IP and port of a Napster server. We send what we will look at as a special Napster data packet, and then we read a response from that server, and we're done. We've made a sort of a call-in request. We'd need to code quite a bit more to keep our connection alive, but this handles a single send-receive flow for now. Over on the server side, we start by booting it up with Python's socket server library, which is an abstraction on top of the abstraction of socket, which kind of handles the server side, and it will sort of quite happily sit and wait for those connections. We can set up a handler, which gets executed when a client connects. And in there, we can grab the socket, we can receive data from the client, we can process it however we see fit, and then we can return a response. Now, there's so much more we'd need to do in a big production system with thousands of active users. But this already is actually quite a potent client-server connection. And with that, we can start thinking about what the actual data we are supposed to be sending between the client and the server, what it actually needs to look like to sort of emulate the classic Napster. So all messages in Napster take the form of a packet that can be divided up into length, type, and data sections, with length and type being 2 bytes each. The value of length is the size of the data section in bytes, so our Napster client and server know exactly how many bytes to read down from the socket. It's kind of a manual process. Now, the ones and zeros of binary aren't something we really have time to talk about today, but I shamelessly will plug a talk I did not for 8th Flight, but I did a talk last year about reading files from a PlayStation memory card, which goes into this in a lot more detail if you would like to know more. What we do need to know is that we can encode these ones and zeros into human readable characters using a mapping called ASCII. And this is what we use in the data portion of our Napster packet. And we also need to know that we'll write our length and our type bytes, which we recall are 2 bytes each, in hexadecimal format, which is like counting from 0 to 15. Only we can do that with 1 digit now, as we have 6 more digits unimaginatively added from A to F. The 0x part here is a way of making all that hexadecimaliness more explicit. With this in hand, we can start to assemble these Napster messages. There were around 130 different ones in Napster, but mine will only be using a handful. These 3, for logging in, for registering files, and for searching for files, are the core messages we'll send for now. We use the length, the type, and the data sections of our message to create tiny agreements between the client and the server as to how they'll communicate with one another. And so the next step is to glue together our connection and our protocol and actually download an MP3. So Napster was centralized, which essentially meant it took on the role of a big MP3 librarian. And when we connected to a Napster server, we registered a list of all the MP3 files on our hard drive, which the server would then plop a record of into the Napster index server. Details on the specific implementation of the Napster server are a little hazy, but I would imagine it was probably a big database. And so when a user ran a search for a certain file, when they sent the message to ask for a certain file, the Napster server would query the index server to see if there were any matches for that file. And if there were matches, it would return a big list of all the users, all the other users it found who had that file. And inside this list would be the details needed to connect that user who had the file that you wanted, which allowed you to initiate a direct transfer with them. And then finally, you would get the file that you were after. And actually implementing this peer-to-peer connection is pretty much the same pattern as we've seen a couple of times now. It's an internet socket using TCP. Here we set up a little data class that would have the file name IP of the server who had that file and the port. and a quick little acknowledge function, which reads a single byte and returns a Boolean as to whether it was a string of 1. We'll use all this stuff again in a second. This is kind of some plumbing. But here we are. We're just setting up another socket, which we've done already a couple of times now. We're connecting to the peer who has the file we want to download. And we then acknowledge that the first byte we receive from them is that 1. That's kind of like a secret little handshake. So we know that who we're talking to is also Napster, a Napster peer. And then we ask for the file name that we want, and we download it in nice 1024 byte chunks. Now, meanwhile, the user we're trying to download the file from has got their own little TCP server running as well. And in their handler that fires when the user connects, they get a socket. They send that single byte of 1. They're doing the little secret handshake to acknowledge that they're in Napster. They receive the file name from the user. And if they have the file on their hard drive, they will send it off in nice little 1024 byte chunks. And again, we haven't really written too much code. Like, I appreciate that I've rocketed through it quite quickly. But there's not been too much code here. And while none of this is production ready, please don't start going to try and run your illicit peer-to-peer service with what's on the screen today. These are pretty much the fundamental building blocks for a Napster server. And there's a few other functions on my GitHub, but this is pretty much the core of what would be running. So we should run it. To see this in action, I deployed the server to AWS. I set up a client on my own computer with I set up another client on another computer with an MP3, and I can show you the client running on my computer, trying to get this file. Ricky Martin is copyright, of course, and I didn't want to tempt fate. So instead, I'm looking to download the distinctive and iconic MP3 that came with all WinAmp installs, the powerful llama whipping intro. And after downloading it, I can actually add this file to WinAmp, and I can click play.
WinAmp. It really whips the llama's ass.
And those 5 seconds were kind of the payoff for the whole talk. If you used WinAmp back in the day, that was probably a pretty concentrated blast of potent nostalgia. If you didn't, that was probably an extremely confusing 5 seconds. But with that, we've actually created our own little version of Napster. And networking is a really fun but extremely broad topic, and we really have only scratched the thinnest scratch into the surface layer here today. But it's been so exciting for me to get to sort of work on this, and also to have the opportunity to share it with you. Hopefully, it's piqued your own interest a little bit into the sockets and protocols that underpin so much of our day-to-day lives. And so I do have the code and some resources for more information for anyone who is interested up on my GitHub. I've got a link here for you. But do feel free to drop me a message on Twitter. Again, lots of shameless self-plugging here. Feel free to drop me a message if you would like to talk about any of this some more. And also, if you have any questions, I would love to hear them. But that is my talk.